Hello everyone, my name is Tabitha, and today we're going to be taking a closer look at Unit 2.4 of Supply Elasticity. And like always, the outline for this video is going to be right here, but just to preface this, if you guys have already watched Unit 2.2 video on demand elasticity, then you are already going to have so much of the basic knowledge you needed to comprehend this lesson. And because of that, this lesson is actually going to be a lot shorter, hence why the outline is super short and even the higher level outline is really short. But let's go ahead and get started. Of course, we have to start with the definition. So what is supply elasticity? So by definition, price elasticity of supply is a measure of how much the supply of a product changes when there's a change in the price of the product. Now, already correlating this elasticity definition with demand elasticity, we can see a few things in common, such as it's a measure of how much something, either the supply or the demand of a product changes when there is a change in the price of the product. And because of this, we're going to be given a formula just like for PED for price elasticity of demand, but this time for PES, which stands for price elasticity of supply. Now let me rewrite the PED formula over here to show you how they are similar. If you guys recall, the PED formula would be percentage change in quantity demanded divided by percentage change, once again this triangle is delta, in price. And now we have something called PSS, which actually has a very similar formula when you break it down. That is going to be percentage change of quantity supplied now, because we're on the supply side, not the demand side anymore. And then divide all that by the percentage change of price. So once again, just to clarify, the denominators of both of these formulas are going to be the same, okay? You're always going to divide PED and PES by the percentage change in price. The only thing that changes is that for demand, it's quantity demanded on top, and for supply, it's quantity supplied on top. And just like in my demand video, I want to go ahead and use a real life example of supply elasticity to kind of walk you guys through the calculations needed for this. Now, if you guys have already seen that demand elasticity video, you know the formula that we're going to be using to find a percentage change, which is needed due to the formula. After I rewrite it, then you're going to already know what to do. But in case you haven't, I'm going to go ahead and re-walk you guys through this so that you know what to do. And I'm going to go ahead and write the formula for the percentage change over here. You have to put this into like your dictionary Bible for exams. You will not be given either of these formulas, but this one is so important and key to understanding how to calculate PED, PSS, and many more formulas later throughout the unit. So let's go ahead and read through this example. For example, a publishing firm realizes that they can now sell their monthly magazine for $5.50 instead of $5. In light of this, they increase their supply from 200,000 to 230,000 magazines per month. With this information, we can calculate the price elasticity of supply of the magazine in question. Now, the reason why I want to walk you guys through this question is because, this is very similar to the IB style of written word problem questions in terms of calculations. So to start, we're going to make two sections. We're going to make the new section, and then we're going to make the old section. In each of these sections, we're going to put two things, a price and a quantity supplied. So to begin, because it says now they can sell their monthly magazine for $5.50, we know that the we know that the new price is going to be $5.50, and then we know that the old price would have been $5, okay? And now when we're looking at quantities, they increased their supply from the old of 200,000 to the new of 230,000. So now let's write down quantities. So first we had 200K, and then we changed it for new to 230K. All right, but now once we have these values down, we can actually do some calculations. And oh my gosh, I am so silly. I forgot to put times 100 here. I'm so sorry, but when you're turning this into a percent, you always have to do times 100. I mentioned in the demand elasticity video that I always forget to do this part, and I forgot it again, but I'm really sorry. Rewrite your notes and add this to the end of it because we definitely need to do it. So now we're going to use this whole formula to figure out the top and the bottom and then divide by such. But to do so, I have to have more room to do this question, so I took away the new and the old values, but that's basically how you find them in a question. So let's just underline them here so that we remember, okay? And then I'm going to put an arrow here so that we remember this one is for this one, and then this one is for that one. Okay, so what we're going to do is we're going to start with the top, percentage change in quantity supplied. We're going to take the new minus the old and divide it by the old. So that would be 230 minus 200 divided by 200. Now, really quickly, I took away the thousands off of all of these numbers in the formula because realistically they cancel each other out when you get rid of zeros. So actually you could make this formula into 23 minus 20 divided by 20. But I'm just going to do this to start off with because there's too many zeros to work with and this just makes it so much simpler. So now we're going to take our calculators, which you will always be allowed to use in an exam, and I'm going to pull up mine. So type in 230 minus 200 will give you 30. 30 divided by 200 equals 0.15 or 0.15, which obviously if you times by 100 is going to equal 15%, okay, which is a positive number. So I'm going to go ahead and write this here. It's going to be 15% for the quantity supplied. And now I'm going to go ahead and erase all of this back again. And now we're going to do the same exact formula to find out the bottom percentage change in price. So really quickly, let's walk through this bottom part here. We got 5.5 minus 5 divided by 5, which in using the calculator, 5.5 minus 5 equals 0.5. 0.5 divided by 5 equals 0.1. So we're going to get an answer of 0.1. And then when you times it by 100, you're going to get 10%. Now, obviously, you just have to work together with these two percentages to put them into this formula where you have 15 divided by 10, each in a percent form. So 15 divided by 10 is going to cancel out to 1.5, and then that's your PSS value. And because it's positive, unlike for PED, where you don't write whether it's positive or negative, for PES, you always write it, okay? And we're going to explain why later on. But now that we know the value is 1.5, we can go ahead and put that into context and relate it to elasticity. All right, like I just alluded, there are going to be a range of values for PES just like there were for PED. So the possible range of values for price elasticity of supply usually goes from 0 to infinity. So I'm going to rewrite the same formula that I did for the PED in that video, where x can be equal to or greater than 0, but then always less than infinity because practically being equal to infinity is not possible. But x will always be in this range of values. And unlike PED, we will come across examples of both extreme values as we continue our study of economics. Really quickly, what this alludes to is, as we saw with PED, there are two extreme cases, okay? There's PED when it equals infinity, and there's PED when it equals 0. Now for PES, the elasticities look the same. This is PES at 0, and this is PES at infinity. Now, while we were talking about demand, realistically, you're not going to get any steeper than maybe this or more elastic than maybe this. Okay, that's because realistically demand is never going to be completely equal to 0 or infinity. However, with supply, as we will explore later on, you're way more likely to get steep values like this or this when you're calculating. This first example I just talked about, when PES equals 0, also mean when it is inelastic. I didn't put that in the title, my bad. But essentially, if PES is equal to 0, then a change in the price of a product will have no effect on the quantity supplied at all. And we can see right here, if this is the supply curve because it's labeled by S, it doesn't matter if the price is lower at P1 or higher at P2, supply is at the same quantity no matter what. Now, if you watched the supply 2.3 video from before, you already know all about short run and long run. But essentially, to summarize it, short run is basically short term when production takes place versus long run is long term when planning takes place for a firm. But right now, we're going to be talking about short term and short run. So in the very short run, sometimes known as the immediate time period, it is impossible for firms to increase their supply straight away, no matter what happens to the price. Now, this is really obvious why this is, but let's say essentially I am a wheat farmer and yesterday somebody asked me if they could have 100 barrels of wheat. There is absolutely no way I could get them 100 barrels of wheat in just 12 hours or just from yesterday and have it ready by right now today. Okay, that's because supply takes time to process. Unlike demand where you just say it and then you get the product and it's done super quickly, supply takes a lot of time. Okay, that's the main difference between elasticities of supply and demand. Okay, and as stated as before, there are going to be extreme examples of PES that we will find, unlike the unextreme examples that you would find for PED. But for example, a perfectly inelastic supply curve might relate to the number of tickets available for a sporting or entertainment venue with the maximum capacity. Oh, this is a very common perfectly inelastic supply question, because essentially it means it doesn't matter what price you charge somebody, whether it's price P1 or price P2, it doesn't matter how much the stadium paid to supply those stadium seats. Because there is a maximum and it's impossible to make more than a maximum, supply is going to be at the same quantity, okay? So essentially, if I went to this Taylor Swift Eras concert and there's 1, 2, 3, 4 seats in one stadium, we are all VIP here. That means that no matter how much it costs, whether a lot or little to make the seats, quantity is the same. You can't take away seats really unless you block them off, but in this example, you can't. And you definitely can't add any seats because there is a limited capacity. In contrast, the exact opposite, when PES equals infinity, or I forgot to write it again, but when it is perfectly elastic. In this example, at the price P1, the supply curve goes on forever, and so the quantity supplied is infinite. This is shown by the curve would theoretically continue on from the left to the right forever, although we don't draw that here, but that basically means that if the price falls anywhere below P1, then the supply is going to go to zero and infinite change. However, at this price P1 that it costs to produce something, the supply is going to be infinite. But now let's look at an example of how that might be possible. For example, in an international trade, it is often assumed that the supply of primary commodities, which we'll look at more in higher level, such as wheat, available to a country for import is infinite. The consumers in the country can have all they want as long as they are prepared to pay the current world market price. Thus, the market in the country will have a world supply curve that is perfectly elastic at the current world market price. Now let's take an example, okay? Let's say, I'm gonna try my best. This is the state of Florida. Okay, that's the state of Florida. And then let's take the state of New York, okay? Let's say New York. Oh gosh, these look so sad. But let's say this is Florida and let's say this is New York, okay? Let's say New York makes all the wheat in some hypothetical universe, okay? And then Florida wants to import all their wheat from New York, okay? From Florida's perspective, the ability to import wheat from New York is limitless because as long as they are prepared to pay price 1 to cover the cost of how much the firm in New York paid price 1 to make and supply their goods, the supply that they have for wheat will literally go on forever, as it is only judged by the price. And if that criteria is met, then the product literally becomes infinite. Now we're going to be revisiting an old but good term is normal goods. Now we looked at normal goods with PED, but now let's take a look at it with PES. So normal products have PES values between, let me write this again, 0 and infinity, and we will now look at these values in more detail. Okay, and the range of values of PES is normally split into 3 categories we're all very familiar with: inelastic, elastic, and unit elastic. Now, if you already went ahead and you watched the PED Unit 2.2 Domain Elasticity video, you're going to know what these terms already mean. So I'm just going to summarize these. I'm not going to go into too much detail while they're here. And for that, we're going to be looking at them on the same slide. So really quickly, I'm going to draw my stupid, simple, not very good little graph so we can look at all 3, okay? Inelastic supply is when the value of a PES is less than 1 and greater than 0. So we can write it like this, okay? And just like the PED curve, elasticity depends on how steep it is basically. If this is inelastic, then this is elastic. The PES curve behaves the same way. So it's going to look something like this, something very close to straight, but still not having an exact gradient of 0, okay? This is going to be an inelastic curve, okay? And this is because if a product has an inelastic curve, then a change in price of the product leads to a less than proportionate change in quantity supplied of the product. As you can see here, this area is bigger than this area. So this change is bigger than this change, and we can word that as a less than proportionate change in the quantity supplied of it, okay? Elastic supply is now the exact opposite. It's where it's less steep. It's more kind of flat, I guess you could say. So that's when the supply curve would look like this. And elastic supply is when the value of PES is greater than 1, but still less than infinity. And of course, it can't equal infinity in realistic terms. Okay, and it's an elastic curve because a change in price leads to a greater than proportionate change in the quantity supplied. As you can see here, the area here is bigger than the area here. So therefore, you can word it by saying it leads to a greater than proportionate change in the quantity supplied. Okay, now last one is really easy. It's going to be when x equals 1. This is unit elastic when the PES value is just exactly 1. And if we take a medium between a perfectly inelastic and a perfectly elastic curve, we're going to get a unit elastic curve that's right in between inelastic and elastic, labeled S for supply. And this is because if a product has a change in price, it leads to a proportional change in the quantity supplied of it. So in this case, we could say this area is the same proportion as this area, meaning that when you word it, a change in the price of the product leads to a proportionate change in the quantity supplied of it. All right, if you understood all of that, then this next slide should be very simple. But the cool thing about supply curves is that when you have a supply and a demand curve on a diagram, we're going to be looking at this in more detail in the next chapter, but it's basically called a market equilibrium. As you can see, supply, it can actually go on forever and it can go through the original axes, whereas demand, it's going to keep going up and off the graph. Whereas the origin of the supply curve is always going to be in the graph. And if you were given a graph on an exam and you were told to dissect whether it's an elastic, unit elastic, or inelastic curve, there is a very easy way to tell, okay? By looking at the origin of the elasticity curves, we can identify what elasticities the supply curve is. And just to be clear, the origin is going to be the point of the supply curve where it crosses the axis. Now, this is all due to mathematical reasons, so it doesn't matter if you know about that or not, but for now, let's not worry about it. Essentially, any supply curve like supply 3 that goes through the x-axis, let's label this, is going to be inelastic. As you can see, it's also the steepest and most like, that's not a straight line. It's also the steepest curve and most like a straight line. This is going to be inelastic, okay? S4, when it goes through the y-axis, when its origin is through the y-axis, it's going to be considered elastic, and it's also seen because it's the flattest line. S1 and S2, however, are a little bit different. See, they both have their origin go through at exactly 0, which would make them unit elastic. And you shouldn't be confused here because although people say that they have different gradients, which they do, this one looks more inelastic, this one looks more elastic, because their origins are right through 0, they're going to be considered unit elastic. And that's how you can look at a bunch of different supply curves, be able to identify what are their elasticities. And of course, there's always going to be some non-price determinants, but luckily we only have 3 to worry about here. I'm so happy. But there are going to be 3 different kinds of, I am so sorry, I forgot to update the slide, but there are going to be 3 kinds of determinants, let's say, okay? And those are going to include how much costs rise, the time period considered, and the ability to store stock, which can also be remembered with the acronym HAT. All right, so to start, this one is fairly simple. How much costs rise as output increases? As we can see, if total costs rise significantly as a producer attempts to increase supply, then it is likely that the producer will not be able to raise the supply, and so the elasticity of supply for the product will be relatively inelastic, okay? Basically, if we break this down, this is what it means. It means that if for some reason, using my 2 little graphs again, but in simpler terms, what this basically means is that if total costs rise, such as production costs that we looked at back in the supply unit, as the producer attempts to increase supply, then it is likely that producer will not raise the supply, okay? This is obviously because if something becomes more expensive to make, you're gonna make less of it because we're gonna assume that all these producers and firms that are suppliers are price maximizers and want to keep the most profit possible, okay? And so therefore, the elasticity here of supply will be relatively inelastic. Now, we're going to redefine these terms in a minute, but remember, inelastic is when something is unresponsive. Elastic is when something is responsive. Now, if total costs rise, we are going to keep supply exactly where it is. We are not going to increase it, which means we are not reacting to it and we are unresponsive, meaning that we will be inelastic, relatively inelastic at that. And however, there's an opposite side. If, however, total costs do not rise significantly, then the producer will raise the quantity supplied and take advantage of the low increase in costs to benefit from the higher prices, thus making more profits. This is the exact opposite. For example, if a producer wants to make 10 more pizzas because they own a pizza restaurant, let's say, and the cost of making the pizzas don't rise or even decrease, which is quite rare, but it does happen sometimes, then in this case, the total costs do not rise significantly and the producer will raise the quantity supplied, okay? They don't have to stop supplying, they don't have to supply less, they will keep raising it as they want it to and take advantage of the low prices as they believe making more product is selling more product. Making these 10 pizzas and selling these 10 pizzas will make them the best profit maximizers possible, okay? Thus making more profits and making it more elastic, because if total costs do not rise and they do react to it, they're going to be responsive. Therefore, it is going to be an elastic supply curve. Now, this huge problem of total costs rising as output increases for firms and suppliers has been a problem for many, many years, ever since suppliers have been around. However, there are two very clever ways in which firms already prepared themselves to avoid increasing production costs that would happen here so that they can continue to supply as much as possible, okay? And those are going to be divided into two categories of unused capacity and factor of production mobilities. All right, the first is going to be the existence of unused capacity, okay? If a firm has a lot of unused capacity, for example, if it has significant productive resources that are not being fully used, then it will be able to increase output easily and without great cost increases. In this case, the elasticity of supply for the product will be relatively high. So basically, this is the idea behind firms and suppliers not always being at full capacity, okay? Let's say I work at a clothing store and I have to sew clothes to be able to sell them. And let's say I have 30 sewing machines, but only 20 are being used. Because I'm not using all 30 sewing machines, I'm not going to have a maximized or full capacity. Those 10 sewing machines that I don't use are going to be my unused capacity. Hence, if I suddenly have a huge increase in demand for my product, I can easily increase the supply much easier because I have unused capacity ready to be used. Okay, I don't have to wait for it to be shipped to me. I don't have to deal with contractors. I have it ready and I'm ready to use it. Okay, and it's really important for firms that want to be able to react quickly to swift changes in demand to not always be operating at full capacity in case they need more resources in the short run. And the problem with not preparing with unused capacity would be if a firm is producing at full capacity, then it is difficult to increase supply without a significant increase in productive resources, which will be expensive. It is therefore unlikely that the firm will increase supply. Therefore, if this happens and you don't prepare with unused capacity, you will not have time to react and PSS will be relatively inelastic. And right here, I'm just redefining. Inelastic is going to be unresponsive. You don't have the resources to respond immediately. So let's say right here, I was already using all 30 of my sewing machines and I got a bunch more orders and my demand increased significantly. Well, I would have to wait a week for my order to be processed, then another week for them to be shipped, and then another week to get the thread and the needles for all my sewing machines. So I would not be able to react swiftly in the short run in this case. Whereas this would actually be elastic, because if I have spare capacity that I'm not using but is ready to go at any given time, then that means I can react swiftly and as soon as possible, and I am very responsive to the changes in demand. This one is pretty straightforward, but FoP, or factor of production mobility. If factors of production are easily moved from one productive use to another, then PES will be relatively elastic, okay? This means that, for example, if I'm going back to my sewing machine example, if I work at like a clothing factory, let's say I make skirts and dresses and they both use the same amount of fabric and the same amounts of machinery and take the same amount of time, okay? If people suddenly stop ordering skirts and my demand for dresses increases by twice as much, then I actually have factor production mobility, because my sewing machines, my amounts of fabric and the time required to make each product are very mobile, because they can easily be moved from one productive use in making skirts to another productive use of making dresses, meaning that I can quickly respond to demand with my mobile factors of production, and I will be elastic because I am incredibly responsive. However, this case is actually not as common as you would think, and most of the time, factors of production can't be mobile to many different products unless they are very specifically related to one market, such as clothing or cars. Therefore, on the other side, if you don't have factor production mobility, your supply will remain inelastic because you then again have to order the resources required to meet that fluctuation in demand because you didn't have it ready already. And a really important point with an elastic demand and factor production mobility is that when my factors are mobile, it will be easy for me as the producer to increase the quantity of output. Like I just said, if I was making dresses and skirts and then my demand for dresses increased twice as much, but I had all the resources ready, it would be easy for me to increase the quantity of dresses that I needed to meet demand. All right, so now the second non-price determinant of supply would be the time period considered. Now, the amount of time over which PES is measured will affect its value. In general terms, the longer time period considered, the more elastic the supply will be. Now, let's break this down. In the short run, firms may be able to increase the quantity of some of the factors that they employ, such as raw materials and labor, but they may not be able to increase all of their factors, such as the number of machines that they use or the size of their factory. However, in the long run, firms may be able to increase the quantity of all of the factors that they employ, and so the value of PES will be much more elastic. So essentially, to break this down, it's basically an extension of the non-price determinant that I said before. However, this time it's considering the differences in the short run and in the long run. Now, like we said before, the short run is basically the time of production, whereas the long run is the time of planning for the production. And in the short run, because it is a short-term time period, it is so hard to increase or decrease supply by huge quantities to meet fluctuations in demand if you don't have the resources prepared to do so, such as what we just said before about mobile factors of production or unused capacity. Okay, this is because in the real world, firms might take half a year, 6 months to plan a clothing line, but might only spend like 2 weeks producing it. But if halfway between the 2 weeks, we suddenly decide that we want to make twice as many clothes as we had initially planned in the long run 6-month period, then obviously it's going to be really hard to get all the resources needed to multiply our production by 2. Hence, it's going to be more inelastic in the short run because we are less responsive or even completely unresponsive to immediate supply changes just because it takes so much time to gather resources. However, if we then stretch out this time period considered to a long-term time period, obviously then we have more time to order, ship, collect, and prepare all the resources to multiply our quantity of clothes being produced by 2. Hence, in the long run, we can be way more responsive to sudden supply changes and it will be much more elastic. And now we have our last non-price determinant, which is the ability to store stock. Now, if a firm is able to store high levels of stock or inventories of their product, they will be able to react to price increases or sudden changes in supply with swift increases, and so the PES for the product will be relatively elastic. This basically is another form of firms or suppliers preparing for swift changes to their supply. For example, if I bought 2 factories and I was working in my clothing brand in just one of them, and the other factory was completely empty, and then suddenly, let's say my demand for the dresses once again increased by 2. Because I have the unused capacity of another warehouse or of another factory or inventory that's just completely ready for me to fulfill and use after my supply changes, then I won't have to worry about renting another place or spending any more time or energy on supplying more of the factor production of capacity or management because I already have it. Hence, I have more places to store all the new clothes that people are going to order from me, and hence I will be able to respond quickly to a swift increase in the demand for dresses, and my supply curve will be relatively elastic. All right, now that was quite short compared to all my other videos so far, but if you're just doing standard level IB economics, you are completely done for today. You can go, run away, take a nap, it doesn't really matter. However, if you're here for a higher level, I am sad to inform you that there's just a little bit more, but I'm happy to tell you that looking at this outline, there's literally only one slide. I promise we're almost done. Now, the good thing about price elasticity of supply in IB economics is that it's very short for a higher level. We only have one more distinction to make here, which is the elasticity of commodities, also known as primary commodities, versus manufactured goods. Now, we learned about this already in the PED or demand elasticity video, but to redefine it, primary commodities are raw materials such as coffee beans, wheat, cotton, anything that builds up manufactured goods, which are when raw materials are turned into secondary products, such as cake, a cookie, a t-shirt, anything that you use a primary commodity for to turn it into a secondary product. The elasticity difference of primary commodities versus manufactured goods once again depends on time. So if we look at commodities, they tend to have inelastic supply, as a change in price cannot lead to a proportionate large increase in quantity supplied. Like I just said though, this relates to time. Let's say we take an example of coffee beans, which is a really common example of this higher level question. In this case, if somebody demanded 100 coffee beans yesterday, but I only had 50 coffee beans ready, I would not be able to give them 50 more coffee beans today, because realistically it takes like months to grow and maintain coffee beans. So obviously I would not have enough time to respond, and it would be an inelastic supply, okay? And you will notice a general pattern with primary commodities having inelastic supplies because they are not things that are made overnight, okay? And this is usually because they have to be grown or maintained over a time period. So this might talk about things like cotton or agricultural products like food. Those are very common examples. Versus manufactured goods, whereas the supply of manufactured goods tends to be more elastic, as it is easier to increase or decrease quantity supplied in response to a change in price. This relates to the earlier determinants of PES. And the reason why this relates to the earlier determinants of PES is because they were all described and explained in the context of being about manufactured goods. In this case, whereas it might take, 6 months, let's say, to grow healthy coffee beans to give to demanders or consumers, to actually take coffee beans and turn them into a cup of coffee might take 3 minutes. Hence, I will be way more responsive to sudden changes in supply to meet demand, and my supply curve will be elastic because I'm not the one taking all the time to prepare the coffee beans. Instead, I'm taking the primary commodity good of coffee beans and turning it into the manufactured good of coffee. Hence, it will be elastic versus the commodity originally being inelastic. And that will be it for Unit 2.4 of Supply Elasticity for the IB Economics syllabus. I hope you have a good night and don't get too stressed out about this. Goodbye.